Okay, what we're looking at here is section B, one variable equations, when we're talking about graphing on the coordinate plane. And so let me grab my red marker here. And basically it's a collection of points that form a line. So if I have a line, it basically means every point on that line is a solution to your equation. In a coordinate plane, the graph of x is a vertical line. So x is a vertical line up and down. So if x is, the number 2 is at point 2, that means if I start at my origin and I go over 1, 2, so here's 2 on my x-axis, that means no matter what group of points, what set of points I have, x has to be 2. So x is 2, and if y was 1, I'd be here. If x is 2 and y was 2, I'd be there. And so every point on the line is your x is 2 is your x value, okay? And it forms a vertical line. Now, in contrast over here, when you have y equals a number, the graph of y is going to be a horizontal line side to side. All right? What that means is if y equals -3, then I find -3 and make a point. That means in every single group of pairs you have, y is going to be -3. If that is the case, the x can be anything it needs to be, but y is always going to fall right here on this line. A quick rule of thumb when you're solving and you want to remember which is which, just remember when you're solving for 1, for example, if you're solving for x, you can remember that it's a vertical line by saying, oh, it's the opposite of y, the opposite of the y-axis. And so if the y-axis is up and down, when you find x, you're actually finding a place where your vertical line is going to be somewhere parallel to the y-axis. And vice versa, if you're finding y, you can remember, well, then it's the opposite. So if y equals something, it doesn't matter where I fall on x, but know that it's going to be a horizontal line down here, wherever your point is. In this case, it's at -3. And so x is like, y is a horizontal line, easy to remember because you just say, oh, if y equals -3, then I know anywhere on this line that is parallel to the x-axis. So when I say parallel to the x-axis, what that means is now, if it's parallel to the x-axis, anything on that x line is going to work as long as y is -3. All right? So moving on this page, if you're following along, it says, notice at every point, okay, graph the following. So we're just showing, if y is -4, then that's on my y-axis, I go down -4. So 1, 2, 3, 4. I put my point in, and so that means that every point for x on the entire x-axis works as long as y stays -4 right in that one spot. Remember, our y will be a vertical line at -4. I'm sorry, horizontal line. I'll write that in there, horizontal line at -4. Over here is where you'll get your vertical line. If x is 5, then I start at the origin and go 1, 2, 3, 4, 5. Make my dot, okay? So for any set of pairs, x has to be 5. Does it matter what the y is? No. So we're going to have a vertical line here parallel to the y-axis, because any number on this y-axis can fit in as long as x is 5. Here we go. So it says, write an equation for the graph of a line that satisfies the information given. They're just asking you to work backwards. So here, the x-coordinate of each point is 17. That just means when x is 17. If they were asking you to graph it, you would just start at the origin, go forward to 17, make a vertical line. So I think you can do B and C if you're following along on that page.